is Spotfire? The Spotfire is a data visualization software, right? So what you do with Spotfire is that once you quantified your data, so once you have a numerical data in your Excel file or text file, whatever format it has, you can actually import it and you can visualize it. So it is a data visualization and data analysis software, right? Unlike image analysis software. Okay. So the first step is to how to bring data into the Spotfire, right? So I have an example here. Desktop, Spotfire training, yes. So it's a world data, okay? So let's open in Excel first, just to see what's the format of this data. So as you can see, there is a country code, that's the one column, then the population of the country, region, which region they belong to, income group, year, and so on and so forth, right? Like GDP, incomes, and the population, how much population, percent of population is living in urban areas, like that. So now you correlate in your domain to this one, right? Let's say, because no matter what we do in science, we always gonna be having the columns and different arrows, right? With the different biological questions and the experiments. Okay, so once you have this data, which is very good formatted, meaning that there is a one name for each columns and the different rows, then it is time to import it to the Spotfire. How to import into Spotfire? First of all, how to basically open Spotfire. It's just double click, right? I mean, this icon and just double click. Okay, but I think I'll just start from scratch. So I just close everything. Spotfire, double click. It will load all the modules, initialization. So we have in CPR we have 5 licenses. Timestamp we haven't purchased it because nobody has come to this conclusion. I mean, but maybe in future, if user wants it, we can purchase it. It's very, it's not that expensive, unlike Imaris and other software. It's just like $150 per year. And the good part is that once you purchase, you can stop the contract and you can still use it throughout your life. Of course, you won't be having an update on this. That's fine. So $150. That's nothing. There are 2 CPR workstations. Yeah, so they are installed there, and one is on my laptop. So just in case if you come and if you want to process, then you can. But then we have some free licenses available, so we still have to purchase the workstation and then install it, right? So, okay, so this is how the Spotfire frontend would look like, right? How to import data? Go to File, Open. This is one way. Second way is this symbol. So there is a menu bar here, and there is a basically icon bar, right? So there are different icons. You can actually go through this file, then say add. So first, one way is open file. So now you go to this particular, say, world data, double click it, or go here, add data table, go to add file, and then add it. This is the second way. Third way is the simplest. You just drag and drop, basically. Just drag and drop it here. Spotfire is intelligent enough to understand the structure of this file, and no matter what kind of file it is, like maybe text, XLS, all kind of formats. So, so in the spreadsheet, if you have multiple sheets, right? In one XLS file, if you have multiple spreadsheets, then it will ask you which sheet you want to look at it. So now it's only, it has one spreadsheet. So now it's a it is giving us what kind of format the column has. So for example, country code is a string format because it's a text. Population is integer, region, string, likewise, and you can change it if this is not correct. But Spotfire is, I think, 99% you don't have to change it, because I mean it's quite obvious for Spotfire to decide what format it should have. But for example, if you have an income or something like that, then you can actually go and say, okay, change it to currency or something. See if you have a US dollar or something like that. But I think in biology, I think most of the time we'll deal with the real data, right? Because not the integer one, but real data, so that we have the floating point data also, right? Decimal. So I just say okay. So now it's going to load it into the memory, right? And the reason why Spotfire is most stable software as far as data is concerned is because it's not like a Excel, right? So basically, if the Excel file is big, then your interaction becomes slow. But what Spotfire does is, in the background, it creates an SQL, the data set, the database basically, and that's why it becomes so flexible, because then every time you click, basically it's generating a SQL query, which is very fast interaction. So the user interaction is more fast using Spotfire than Excel. And also there is no data limit. Okay, so if you have a big file, then it also actually supports big data. Right? But I think in biology, I haven't seen any data like that. But maybe in STEM, right? If you have many embryos, many cells, and time-lapse data, then it might go to gigabytes. And I have one example for the siRNA screening for that. Okay, so the data, so data size is not a limit. Okay, once you load the data, in the left-hand side, you will see all the column names stratified by their category. So they are numbers and they are time, because time, year is a time, as a category of time. And then there is a categories, meaning that it is just text, it's not numerical data, but it's a category data. So you see how smartly it has stratified your columns into different categories. So it is easy for a user to decide. Okay, so by default, it will always give you, most of the time, the bar charts, right? And everybody knows what is bar chart, right? Bar chart is like x-axis is a category, y-axis is your value, right? Now, by default, it is giving us just the guess, basically. So it's a region, that's your category axis, and y-axis is a row count. So what it tells you is that the region is my x-axis. So all these are the regions in the world, and this is the count. So basically, I can tell how many sample size I have in each region, basically. Yeah, this is bar chart. But the good part here is that you can actually change your y-axis according to your need. So maybe I'm interested in seeing the the urban population, percentage of urban population. Let's see what happens. Okay, the majority of them actually in Europe and the Central Asia, of course. I'm not surprised by, right? And of course, North America, well, that's surprising, okay. And South Asia, that's less. That's comparatively less. So these are the different things you can. On top of this, what we can do is, you have to click to this filter, okay. What filter tells you, it basically creates another visualization of the same column that you have it here, but in a more interactive way, right? So you can basically interactively control it. So for example, in population, you can actually use this slider, right? So basically, you can limit your data and see the visualization. You see right away, you can see the reflection of what you're doing here onto the data, onto the plot. So I'm changing the population. Maybe you can say, okay, I'm not interested in looking at the Europe or Latin America, only this one you're interested in, then you can actually switch on and switch off. Okay, it's very it's a self-explanatory, right? For example, power consumption. Maybe if you want to look at how many regions are actually beyond using this power consumption beyond this limit threshold, then you can actually change this threshold and see the effect, like how many percentage of urban population are using basically power consumption. Okay. Also, it's important here is that once you select a particular y-axis, you have to select the aggregation, right? What do you mean by aggregation? Because in one region, there are so many countries. Within one country, there are so many samples, right? Then how do you want to aggregate them and show it onto the y-axis? That's your choice, right? So by default, it will show it as a sum. Yeah. But then you can change it to average. Yeah, that makes sense, because then you can compare it, right? Then you can go for count. This is what we have seen before. That's a histogram basically, right? It's just a histogram. So when the y-axis is a count, it's a histogram, right? Okay. Yeah, likewise, and there are so many median, standard deviation, so many, all this first order statistics you can actually aggregate that quantity into. That is possible. Okay. On top of this, one can actually stratify your population based on color. So if you click here, the down arrow, you can select on what criteria you want to stratify this population, on what criteria you want to stratify the color onto this population. So maybe I would go for region again, right? Sorry, region. See, so it is going to show me regions stratified by the colors. And there are so many things you can actually control. So maybe in the country name, okay. Now we haven't looked at actually the country name, but let's look at go and look at it to the country name now. So y-axis is now only the region, but the good part of Spotfire is that you can actually add as many as category as you want in x-axis. So now I would add the country name so that I know within this regions how many countries are there, and I want to look at the urban population, percentage of urban population, average population for that particular countries. You following, guys? Okay. Just ask me any question. Yeah, that's all about the bar chart. Okay, but this is not that impressive, right? Because one can do it everything like in MATLAB or the R, any other programming language. What is good part of Spotfire is that it's interactive, right? So you can create multiple visualization, and we can make it like real time. So once you click on a one particular location, it should show the information of that particular location only, kind of, right? So for that, I will close this and I will directly tell you this example. So if you open Spotfire, one can create this nice visualization on this data set. For example, this one. You see now? So this is one plot, okay? By the way, in one, this is what we seeing here. Actually, this is called as a page. Okay, this is a page. Within one page, one can have a multiple visualization, right? One can have a bar chart, one can have a line chart. We're going to see this. What date? But right now I'm going to tell you what Spotfire can give you, and what is the capacity of the Spotfire. So in this plot, this is a line chart. X-axis is a time, y-axis is population, and they are stratified by the regions. You can see here, right? So of course they are increasing, the populations are increasing over time, but the majority of the increase is in East Asia Pacific, of course. North America, not that much compared to that one, right? But the good part, if you just click here, it's going to show me the stratification based on the countries for that particular region. You see, if you click here, South Asia, of course, India is largest. Then in the East Asia, China, followed by Indonesia, Japan, likewise. Okay, similarly for North America, yeah, United States, Canada, likewise. And you can change this y-axis here, actually. Now the x-axis, because it's tilted, right? It's a horizontal bar chart, so you can change this population. So you're understanding this interaction basically. So what you just click on one particular plot, and it gives you an information about the other one, right? Similarly, you can create another plot which would interact based on what that country belongs to. So for example, if you click here, right, and then it gives me what kind of that's like a pie chart, but pie chart based on the income type for that particular region. So majority of the population is basically high income in the European peninsula, right? And if you go to East Asia, of course, majority of the upper middle income, right? Makes sense. So likewise, I mean, there are so many visualization you can actually create in one page, and likewise you can have multiple pages. So basically, you can extract all kind of information that you want to extract from the data that you have. Because if you go back, it was just a simple Excel file, right? But it's just that you just have to pose a question and create a particular charts, and then you will get an answer. Okay. Also, you can create a scatter plot. So if you just select a particular, let's say this region here, South Asia, and this is the population versus urban population. So that's a percentage of urban population living, and this is the entire population. Okay, so if you click here, it's going to give me countries. Basically, all the spots are basically countries, and if you select, okay, I'm interested in actually looking at what this country is the China. So it gives me this label basically, right? So all kind of information is available. So it's very interactive, right? I mean, this is not possible in MATLAB. You have to actually write a program for this one, instruction for this. So this is very interactive. Okay. So this is all about just on the world data, okay, which is not related to us, what we do here. But I thought it's good for you to just understand what Spotfire can do.
Is it always like this, that it's explained, or where can you find information?
This is just an example I gave you. Okay, this is from the Spotfire. Okay, that's why I gave you this example, because this is very easy to understand, right? Because everybody knows what a region and population and things like that. But then I'm going to give you the example that we deal with here in CPR, and that's it.
For example, here the source file would be an Excel file that we will present.
Yes, exactly.
Things like the maps and other stuff that embed.
Oh yeah, exactly.
Something like that, right?
Okay, so for the maps, that's the only different thing that we don't do here actually.
Yeah.
Okay, because we don't deal with the mapping stuff, like all the geographical location and stuff like that. Where was it? It was here. This one.
Yeah.
Okay. Because for this, every rows there has to be one column called as a longitude and latitude for that particular country. So if you have this information in your XLS file, Spotfire can detect and actually locate geographically what that country would be. That's possible. So if you click here, you see that's the South East Asia region. If you go to South Asia versus India, then all neighboring countries. So if you click here, that also does that. So that's the lower middle income. Yeah. So that's what. But I think in biology this doesn't make sense. But I have one good news for you. So basically, you can link images to the data, right? Okay, I'll discuss this example with you. But of course, except this map, all other functionalities of Spotfire one can use it for biological data. Okay. So this is all about this example. In order to close, just click on close and say, if you want to save it, just say yes, or just then say no. If you do not want to save it. Okay. Let's start with an example, practical example. So I have, before that, I will just explain you what this experiment is about, actually. Okay. So this is a scanner software, which we do in CPR. Florina, I think you may be not aware of this one, but that's basically a high content screening software. It's a scanner microscope. So here there are two channels, DAPI, Cy3. Cy3 responsible for certain protein expression, for example, right? And the interest is that it actually gives you a foci-like structure within the nucleus, right? And what I did is I first segmented the nucleus and then segmented foci, Cy3 foci as a sub-objects. Okay. So I'm not going to explain you how I did it and all these things, but I have extracted these parameters, total intensity, mean intensity, and circularity factor, area, like that, and also the foci count. I mean the PML bodies. Let's call us PML bodies, but then PML bodies inside and outside. But let's focus on inside. Okay. Once I have done this experiment, this is called as the image analysis experiment. All right. Then analysis and then export the table. This is what you do basically normally when you're dealing with the scanner software, and then you just save it. So once this is what I did here. You see this main and this main PML in, right? So main is basically a main object, meaning that this file has all information about the DAPI channel. That how many cells are there, how many wells are there, within wells how many cells are there, within wells how many positions are there, within one position how many cells are there, likewise. And what is the mean intensity, DAPI intensity of individual cells. This information is embedded in this file, and this main PML in is a file which is for the foci information. Okay, that this foci belongs to which cell, that cell belongs to which position, and well, and so on and so forth. Okay, so we have basically 2 files, but let's stick to the first file, and then maybe later that is an advanced level, that how to combine and how to concatenate multiple files. Just remind me if I forget. Okay. So first we will deal with only the main data. Okay. So how to import this file? Just drag and drop, right? Just drag and drop. Let's see if it works. Okay. You have to. That's basically kind of a sanity check, right? If everything is okay, looks like everything is okay. Everything is fine. The data is okay. Just hit say okay. Okay. As I said, by default it will give you a bar chart, right? And just it's an initial guess by the Spotfire. This X and Y axis. It has nothing to do with. I mean, this is the right way or wrong. That all depends on the user. So in X-axis, first my interest is basically to go for the well here, just to see how many wells are there. Basically there are 2 wells. Okay, fine. And the row count, meaning that how many cells are there within one well. Okay. But maybe I'm interested in seeing, I want to see the number of cells but stratified by position and then well, or other way around. So I would select the position here. So within one well there are these positions, this see here, and this is the count for every position. Basically every field of view, these are the quantifications, these are the number of cells present in that positions. Okay, you can actually color by now based on, let's say, well, so that we know which they belong to, right? Or you can actually add another criteria on this one. So maximum intensity of that becomes completely stupid, right? But you need a justification that why you want to use the two colors basically. I mean, I'm happy with this one, right? Just to stratify. Okay, and then again, as I said, you can use let's say total Dabi intensity. Maybe I'm interested in seeing how many cells within a positions are actually in a G2 phase or G1 phase, because that is defined by the sum intensity of Dabi. Okay. So roughly, just to get an idea, okay, I think the distribution is not homogeneous, meaning that it's not equal basically from well 1 to well 2 that I can see from here, that the majority of the wells whose Dabi intensity, sum Dabi intensity is less in this case. Right? So there is something interesting in this particular well, for example. Okay. But so again, it depends on what biological questions that we are actually looking for, right? So if I'm interested in looking at how many populations are there which is at the G1 phase, then I would go for, I would not use this chart basically. Bar chart will not give you that information. I would go for the scatter plot. Okay, but I will come to that point later, right? First stick to this one.
What is the position here? Is that one image?
The position is, okay, maybe I can show you here. So we go to here, well, I go right click, well overview. So these are the individual positions within this well. That's the field of view basically. So there are 1, 2, 3, 4, 5, and I think 25 positions. Okay, so there are 25 positions for each well. This is how the image was acquired, right? And then we have segmented individual field of view, which is a position, and every position will have certain number of cells. This is what it's showing here.
So one position is one image.
One position is one image. Yes, exactly. And if I go to the row count, then that's basically, so it has 16 cells in this position, which belongs to the first well, right? Okay. So this is all about this one. How to change? Let's not do the coloring stuff, or forget about this position. I would like to show you how to basically visualize bar chart as a histogram. Okay, let's start from that. So as you know, the histogram is in x-axis. We have a quantity that you want to look at it, right? So for example, I'm interested in looking at the histogram of the sum of Dabi intensity. Okay, so I would just remove this, go and say total intensity of Dabi. Okay, I will not stratify by anything, and here it's a row count. Okay. Now, if you right click and say auto bean, you know the beaning stuff, right? Beaning meaning that my category axis now is the total intensity of the bean, and I'm dividing this whole range of data set into 5 beans, right? From minimum to maximum. So there are some cells whose DAPI intensity is very extreme, and some cells which are very low. And with this slider, I have a choice of changing this beans. And now you look at it, how the data look like. See here? So that's basically what is roughly showing me, okay, actually there is this one peak here and then another peak here. So I think this must be belonging to G1 phase and there must be a G2 phase. But again, it's not clear, right? So maybe the data is, I think there is something wrong with, it's not wrong basically, but this information is not actually useful in that way. Okay, I have another example for that, because this is an example I gave you for this foci stuff, right? So something gone wrong with the DNA stuff, right? Now, but just to look at that kind of data, I will go back and Spotfire. So this is my well, and this is my, change it to total intensity of DAPI, row count. Can you see now the 2 peaks? Right. So first peak, that's the G1 phase. There has to be a G2M phase, and whatever in between should be S phase. Yeah? But again, with one information, one dimension is not sufficient to decide. But at least G1 and G2 can be detected from this histogram. Right. So this population here, G1, this is G2. So now we have seen how to convert the bar chart into the histogram. The histogram, the only difference with the histogram bar chart is that the y-axis, this one, is a row count. That's the histogram. And if the moment you change it to, let's say, the circularity factor, which is basically shape of a particular shape of a nucleus, and go for the average value, that would change completely. That's bar chart. Okay. And if you change this x-axis into some category, then it becomes bar chart. Right? So if we go to the, let's say, I would go for parent ID. That's basically, so there's only one parent ID. Let's say -1, and this is just a number basically. Right? Okay. So you understand now this one, the DAPI intensity. There are 2 peaks, so G1, G2, one can recognize. So actually, the cells are in G1 and G2 phase. So I'll go back to this original file. Yes. I will get back to you with that example when we look at the scatter plot. I have that example here. Okay. Because as I said, in order to detect if the cells are in the G1 or G2 phase, the histogram is enough. But to detect if the cells are in mitosis or in S phase, this one dimension is not enough. We need a mean intensity of DAPI and the sum intensity of DAPI. That's like 2-dimensional information. And the moment it goes to 2-dimensional information, that becomes scatter plot. Right? Because in scatter plot we have both values, basically 2 dimensions. Okay. Let's go back to Spotfire. Setting here. Right. So, as I said, if it is a well here, there are 2 wells and the row count, and then I'm going to say that's the bar chart. Okay. Enough of bar chart. Now, how to basically change the properties of the bar chart? Okay. So to change the properties of bar chart, either you can actually go here, but it's only one is present. Let's say color bar. But there are so many other stuff that you can control. So just right click, go to properties, The first tab is the general. It's just the title of this one. What title you want to give to this particular plot? Maybe whatever of your interest. Data. You don't have to do anything here. Appearance. We want to look at the vertical bars because by default it's vertical, but you can actually go to the horizontal one. So see, oops, it's just inverted, right? It's transpose. By default it's a stacked bars. One can actually go for the side-by-side bars, but it's not, nothing is reflecting here. The reason is because we haven't stratified by the categories, right? So if you go here and change this color by let's say nuclei. Okay. So I will tell you what this nuclei means. So while creating in this in scanner, we have created this one gate, which we define that as a proper nuclei which are healthy nuclei, and one which is completely debris kind of structure. So those who have got 1 in front of their rows, they are healthy nuclei, and zeros are not healthy nuclei, right? So this is what we are exactly doing here using this one. So there is a one column whose name is nuclei, which is just the binary number, right? Which will have binary number 0 and 1, and we are stratifying this based on this nuclei color. So as you can see here, I will just change this to vertical, sorry, so that you understand this properly. So you can see that within this well, these many percentage, you see the sum of it is, we are not seeing actually here, but let's go for the count now, row count. See, there are 16, and here there are row count is 240. Here it's 183 and 30. So there are 13 basically cells which are not nuclei basically, or yeah, the object that we have segmented is not nuclei basically. Right. The meaning of this stratification, as I was telling, this 100% stacked bar is this one. So when you click on 100%, no matter what you have here, it always goes to the 100%, and with respect to 100%, it calculates what's the contribution of that particular. So that's basically a relative bar chart. Isn't it nice just to look at it like, because maybe I can say, okay, within this well number 1, I have only 6% of population which has basically debris, which is okay, and only 93% are healthy cells. Good. And you can compare that with respect to other wells, right? And likewise, you can have other criteria, right, based on this. So this is what you can control with this 100% and the stack bars. Okay, here. Stack bars. Okay, bar width, you can control the width of the bar. Right. Transparencies, this may not be interesting for the bar chart, but I'll come back to you with this transparency when it is important. Show the shadowed indicating unfiltered data. Okay, I will cover this point when we use this marking stuff. But sort by values. Okay, so if this had been only this thing, let's say none here, remove this color stuff, and if you go back, let's go back to actually position. Forget about the wells. Okay, right click, properties. And here I would say, okay, sort by values. That's position. Right click, formatting, category access. Okay, anyways, I'm not, I think we can sort these values also. Okay, you can sort this bar chart, basically. But this is inactive. There's some reason why it's inactive. But, okay, let's try with some other example. Right click. Appearance. This is inactive. I don't understand why. But there is a possibility of sorting with respect to values. So it goes from decreasing order, or you can change it from increasing to decreasing order. Right? Okay. Yes, that's also possible. So this is about the formatting. Font, of course, you can change the font. Let's say, so as I said, the x-axis is the category axis, so you can change the font here. So category axis, you can change it to this one, like this one, and likewise for other stuff also. You can do that. Okay. This is all about bar chart. Again, other properties, value, colors. As I said, you can either do it from here or you can do it from here. Go to properties. I would go for, again, as I said, position, just to give a different color to the positions. That's what I would do. And then say now. Okay, so it's a different color to different positions. You can change, by the way, this color if you do not like it. Color, you can change it, right, for example. Just double click and make as many intervals as you want, right? And then the color will be stratified based on that particular intervals. Okay. So can you see this reflection here? Right. Okay, labels. As I said, what do you want to display on the top of the bar chart? That's what the label is, right? So if you say all, the value will be displayed on top of the bar chart. That one value is for this y-axis. So my y-axis is now the sum of mean intensity of the background current. So that's basically the values will be displayed. Okay. Tooltip. If you put a cursor over there, what value it should display? So right now it's displaying what position that come from, what is the y-axis value, and what is the position again. Yeah, doesn't make sense because it's color by value, right? But you can actually add as many as you want. So maybe if you're interested in knowing what is the circularity factor for that particular, let's say, position, then you can also, and then I want the aggregate value, which is the average value, I can also display that as a text. Okay. Now if you put a cursor over here, it should show me the average circularity value, which is 1.22 for that particular position. So many information you can actually extract just by putting the cursor on that particular point. So that's all about the bar chart. Right click, format, vertical. What else properties that you can control? Labels, tooltip, we have seen. What is a legend? Okay, legend is also like what we see here. That's a legend, basically, right? So what do you want to show? You want to show as a color. Right now we have just used color, so that's basically just want to display it, right? But there are so many other stuff we can do it. But I'm not going to cover this in the bar chart. But there are some other charts where we can have not only by color, but we can actually stratify by shape, size, and stuff like that. In that case, it is important to have this legend besides your plot. Okay, what else you can control? Trellis. Trellis is okay. So this is one plot, right? And if you're interested in looking at the similar plot but stratified by some particular number or some particular criteria, that is called as a trellis. Okay. So maybe, for example, I want to look at, maybe this is not a good example, but if you go back to this world example, right? Maybe you are interested in this bar chart by region, but stratified by different countries. Then you can actually right click, go here, and say in trellis, you can say panel, I want to stratify this chart based on, let's say well, for example, right? That makes sense. Yes, because my x-axis is a position, and every well has all these positions. So when I say trellis by well, meaning that I should have the two such plots stratified by well number 1, which is here, and well number 2, and these are all positions. So x-axis is common, y-axis is also common, but it's only stratified by well. That's a trellis. Imagine if you have a 96 well plate, then I would go for trellis by well, right? Then you have all the quantification if it is a replicate, right? stratified by different wells, and then you see basically what's happening in one particular position or one well. Okay, these are the numbers basically. So I can clearly see if this had been a replicate, there is something gone wrong actually. Well, here for example, or well, is there any? Yeah, for example, this one. You see here, this position, this is small and this is high. So if this had been a replicate, there is something wrong at that particular position. But imagine this as if this is a well, then I think the replicate makes sense, right? Because then you can create a replicate based on different wells. So there are different questions you can pose and the answer you can get, right? So this is all about the bar charts. That's it. Properties. Trellis. Then the line curves, you can basically extract and draw a line, horizontal line. You can draw vertical line. You can draw a vertical line based on maybe position. So position doesn't make sense, but let's say median, minimum. Okay. You see the minimum position and the average value of the entire population, minimum to maximum. That's all. But in bar chart doesn't make sense. I have an example for you guys that how you look at it actually. Okay, so right click, then trellis error bars. Maybe you are interested in looking at the bar chart, but also, so if you go to this one here, not the EML count, but the wells, right click, and here you go to total intensity of the API, right click, properties, go to error bars, vertical, and here you say that what is your x-axis, y-axis, a sum of intensity the API. So I go to the total intensity the API and go to sum, standard error of right? That's this one, and then lower one is also the same. Well, the standard error is so small, that's why you are not able to see it, right? But there is a standard error basically. You can change that to also error. Maybe I'm interested in also not the error lines, error bars. Not the standard error, but the confidence interval. 95% confidence interval, lower. So it has to be upper. This is upper. Same thing here. 95% confidence interval. Now this is lower. You see here now the confidence interval. So this indicates that the confidence interval is so low in this case. But then let's see how it affects stratified by positions. Oh, there are a lot. See, because we are looking at all the position, all the position collected together in one well, and then there is also deviation. But now if you see the deviation within one position is basically significant, right? But for what? For sum of total intensity of the API. Right? So if this had been like, for example, if you go to some well which has, let's say this one, for example, right, well number 2, this has the least deviation for the total API intensity. So there is something interesting in this particular question. So such kind of example, such kind of a question that you can pose and see it. Right? Okay. So this is all about position. Well, error bars subset is not important for you guys, and show height. Okay. So we have actually studied all the properties that you can control for plotting the bar chart. Right. So this is just the one visualization, but there are so many other visualization one can actually utilize to pose different questions and get a different answers for that. Right. So it all depends on the scenario. So the second, which is very mostly used, is the scatter plot. Okay, by the way, how do you basically see? It's a very self-explanatory. There are the icons here, right? You just click there and that particular kind of a plot will be generated on that particular page. And if you want to retain with this particular plot and you don't want to overwrite it, then just go to the second page. You see this plus sign, so you can create as many pages as you want and create different visualization. plots on that.
Okay. Several on one page.
Several on one page, that is also possible. So if you go to the plot here, for example, and then let's say right click, or maybe just click here, say scatter plot here. You can go to heat map. All these things are here, and then you can arrange it according to your need. Right? But of course, I mean, if there is a pages, then I think I would go for the page, right? Because it may not be sufficient the size. Okay. Let's go for this scatter plot now. Okay. In the scatter plot, see, this is very interesting, scatter plot, and it's very. I think most of the time I like scatter plot, and this is actually you can understand why the Spotfire is called a Spotfire, because there are all the spots here, right? So majority of the time you will be actually dealing with the scatter plot, because you are always interested in looking at how one variable changes with respect to other variables, right? Okay. So in this case, what I'm looking at is the total DAPI intensity of individual cell with respect to total. That doesn't make sense, but go for the mean intensity of DAPI. So in y-axis, I have, so every spot here is a cell. Okay. And why it is cell? Because marker by, I'm saying this marker by is a row number, right? Because every row in my XLS file should be displayed as a spot. That's why it's called as a marker by. But you can change this to other stuff also, like say object ID. It won't change much, but it will be the same, right? Because every row is has a unique object ID. So that's a row number. Okay. Now color by, how do you want to give color to individual cell, no matter which position, which well they come from? So maybe I'm interested in looking at the circularity factor, let's say. Okay. So the minimum is 1 and maximum is 5. And this is stratified by the colors. If you're not happy with this one, just go to properties, right? And then just click here. It will give you different colors. So different range. I think I discussed in the bar chart also this, right? But you can create different intervals stratified by different colors. And now I know, okay, if those which are actually basically blue, they are actually more circular than the one that doesn't. Okay, so these guys are basically circular one here, which has a low DAPI intensity and low mean. Okay, mean DAPI intensity. But this is normally the plot would look like. Okay, this is just a scatter plot. Now the question is, how do I define what is these guys here? What do you think what these guys should be? What these cells should be? Whose mean intensity is more and DAPI intensity is also the average intensity? These guys. What do you think they should be? They should be like a G1 phase, G2 phase, or mitotic, or S phase. Okay, first you have to understand what is the mean intensity. So the mean intensity is the sum of all the pixels within the nucleus divided by the area, right? And as you know that in mitosis, the cells shrinks, becomes more circular, so the area is less, and DAPI intensity is more, right? Because it's about to divide. That's why you can see that these guys must be from the mitosis, or they must be in the mitotic phase, right? These one will be in G1 phase, these two will be in the G2 phase. But of course it is hard here, right? But that was a question that you asked me, right, Dimitrios, that how do I define and how do I use a scatter plot in order to define the mitotic? Okay, by default, if you want to mark it, you can actually do it using the square, this one, like just drag and drop, not drag and drop, but just draw a rectangle basically over the region that you want to, that you are interested in. But if you are not satisfied with this rectangular stuff, then just press Alt key and you can draw a region. These guys will be selected.
So when you press the
Alt key. Alt. This one. This is selected. Like once. Let's say maybe I'm interested in only understanding what is happening in the cells or the foci for the cells which are undergoing mitosis. So maybe I would do like this one. Okay. Right click, mark rows, and I would say okay, filter to. meaning that but this, you have to do this only if you want to completely ignore other guys. Okay, then if I say filter to, I am only dealing with these guys. Right. Similarly, you can do the other way around. So if I say Control Z again, right click, mark rows, and I say invert, meaning that I'm not interested in these guys, but I'm interested in the other one. So when I say invert, you only deal with this one. And then you just say right click and say, okay, filter to. I'm not interested in this one.
Can you assign the state?
Yes, that I will cover in the marking stuff. Okay, how to do marking. Yeah, that will be marking. But this is just quickly how you can actually stratify and filter out basically. Because if you are dealing with the gigabytes of data and you know prior that you're not going to deal with the cells which are in the G1 phase, but you are only interested in S phase, then it's better to do the stratification in the beginning and then filter all the rows.
But I would do it based on a different plot because you don't see it that well.
Yeah, exactly.
Maybe on this where you saw
the bar chart.
Yeah.
Yeah. I mean that's something that you have to decide as a user what information is relevant and which plot is sufficient to decide this factor. Right. As I said there also that in addition to the color, there are two different criteria which you can stratify. One is the shape, other one is the size. So shape, maybe I'm interested in those. Shape, maybe I want to stratify based on area. But doesn't make sense because shape has to be, there has to be fewer variations. So maybe should we go for well? Let's go for well. Right. So those that are, imagine that you have multiple wells, then only one position belongs to one well basically. And size by, here I would say area or perimeter or whatever, right? Or elongation factor, let's say. So those which are actually more circular or the diameter, bigger the diameter, the bigger is the elongation factor, meaning that they are more ellipsoid in that way. So you see there's so much of information is embedded in one plot, which is very hard to actually generate as other softwares. Right? And here you know, okay, I think there is something interesting with this guy over here. Then if you want to select such event, just say control, click control, select multiple event like this, and again right click and say mark, and then you only focus on that particular class. Okay, that's possible. Okay. This is all about the scatter plot. What else we can do with the scatter plot? Oh yeah, one more thing. So if you put a scatter plot, if you put a well in x-axis and total DAPI intensity in y-axis, and you say I do not want to use shape, I do not want to use size. These are all the scatter plot, right? But I want to see actually individual cell as if it's a funnel or basically a capillary, and you are putting actually all the cells into the capillary, and depending on what is their y-axis, meaning that here the total intensity, they should show up. You understand my point? In order to, because right now basically they are overlapping on top of each other, right? So you don't see actually how many cells are there and what are the, of course you can see what are their y values, but there are so many multiple stuffs are going on here. They are overlapping on top of each other. So one way is that you just right click and go to format, font, x-axis. There is something called as a size, marker size. Okay, so you can reduce the marker size, but again see it's reducing the entire stuff, right? So to deal with this one, what you should do is you go to insert, calibrated column, and here I would say I want to make a random number. So just say rand. You can give any number you want. One is enough. It's basically a scene point. So what I'm right now doing is I'm just making a random number as a column, and I'm concatenating that column to the main file. I will give you an example. this is table. This is the number that we have actually generated synthetically. It wasn't present before, but this is something we have generated now, right? See the significance of doing this. I go back here. Now you say, okay, I want to use rand as my x-axis, right? This is DAPI, right? And now I want to say right-click, properties, go to trellis, and in trellis I want rows. I don't want any rows to be stratified, but I want column to be stratified by wells. Okay. Now see what happens. This is one well, this is a second well, and you see all the cells for this one well are basically represented as if they are actually in the funnel or in the capillary. Isn't it a good visualization, right? And then you can control this y-axis, and you can visualize the mean intensity of DAPI. Okay, so I can see that actually they are equally likely, mean intensity of DAPI. But maybe I'm interested in PML in counts, maybe foci count. Oh, foci count, I think they are also kind of similar, right? But you can't judge it based on this one. But here is just to validate your experiment. How good is your experiment? Or maybe if this had been a replicate, you can see the consistency, right? For comparison, I will cover this box plot, the t-test and stuff like that. I will cover that point later. But this is only limitation for the Spotfire, for the scatter plot. Okay, but maybe I'm interested in knowing what is the median value. I would like to also display the horizontal line which represent the median value of the y-axis. That is also possible. So how do I do this? So go to lines and curves again, horizontal line, edit this, go to average value, and average value, what is this? The average value of the y-axis. Okay, that's the average value of my y-axis. So that's the count basically, and if we change this, the average value would change. So if I'm going to, let's say, go to circularity factor, you see how it's changing. So I can display the average value also, or median value, whatever the value that you want to display, as a horizontal black line, and also the individual cell as if they are actually in the capillary, right, of that particular value. Again, you can actually stratify that properties, go to trellis. Maybe I'm not interested by well, but I'm interested in stratified by positions. So go to trellis again, trellis, and instead of well, you can actually go, or in addition to well, let's say I'm adding the position now. Position. What happens here? So this is well number 1, this is well number 2, and for every position there is a vertical line, as if this vertical as the capillary is. And each point here is basically a single cell. And now it tells you, is there any consistency within all the positions for one particular value? It certainly doesn't look like, right? Because some of the positions are very high actually, the circularity factor. There may be some reasons. Maybe you want to get rid of these guys, so you just select them, right? Just take time. I think it's already selected. Right click and say filter out. So you can consider them as an outlier, for example. But you have to be very careful while doing this one. But there is a possibility of doing all this stuff, right? If you change, no, it won't be, because the problem here is that we are giving an x-axis position as a random number. Yeah, and if you do what is the question?
If you just remove the wrong thing,
a random thing. If you remove this random thing, but then
go ahead.
Yeah, right. But they will be in one position, right?
Sure.
And they will be overlapping. So to get rid of this overlap, we are just creating a fake x-axis information.
Dimension, just to visualize things.
Yeah, exactly. That's just to aid in the visualization. Okay. That's it. So this is all about, again, the same thing. we can change this criteria or change the properties of this scatter plot by going to the properties again, and it's a similar thing like x-axis, that's a rand, y-axis you can change it from here also. By the way, you can actually add it on top of one, so you can have a multiple y-axis, not only the circularity factor, but I'm interested in actually total Dabi intensity. There's an x-axis, go for multiple axis. It's not showing up. So with multiple columns and y-axis has not selected, the column names has not selected. Okay, so the marker by column names. Okay. Right. So this is it here, but there is a possibility of doing the multiple stuff. Okay, so go to sum average. Maybe it's because the trellis done. So if you remove trellis and then you add another one, that's possible. Okay, so with trellis it's not possible, but you can actually add multiple y-axis evaluator for the same x-axis stuff. Okay, that's possible. And then maybe color here by not by the circularity factor, but by well. And then you come to know, okay, what's happening. Okay, so this is all about this. Then go to properties again, size, as I discussed before, size, shape, labels. Again, you can actually give labels as what you want to display, right? So maybe I'm interested in knowing the area, basically, of the marked row. So if I mark this one, it will show me the areas, basically. Right. That's just an example. Right? Properties again, tooltips, legend, same thing. Okay. This is all about the scatter plot. Now the interesting thing is with all the fancy charts, the plots that we can actually extend. And for that I have a data, basically an siRNA screening, which is I think around 7,000 genes that we have done siRNA screening on, and then I will give that example. But I think should we take a short break for this, like 5 minutes or something?